So I teach two courses here. One is this kind of introductory drug discovery, and the second course is more advanced, where we do both class teaching and also behind that wall here, there's a lab where we actually screen drugs and we discover drugs. And this is sort of like a research-based course where, if we're lucky, we may end up publishing something at some point. So in between academic years, I'm also busy with a summer program. All of us research active faculty, we take in undergraduate students here. So if you're interested, if you have a free summer before you come in, if you are still thinking that you can join us for the summer, again, we do research-based. Every faculty here may take a student for the summer to do research in his or her lab. I take about 20 to 30 students every summer, again, to screen drugs, and we do screen drugs against microbes. So I'm by training microbiology, so I combine microbiology with pharmacology. So as a result of all of this, I and another faculty here that teaches business, Joel West, we spun out a company called Shield Pharma, where two of these drugs that came out of these screens that students do are now being developed for anthrax and botulinum, two very dangerous pathogens. So that slide kind of shows my teaching and a little bit of research, but I do balance my applied research with more kind of academic research, where I intensely study anthrax. Here on campus for the past year, we now do have real anthrax. And what we study is how anthrax is being transmitted by insects. So we have both Drosophila and mosquito, and we ask a basic question. Our basic question is, if anthrax is so deadly to mammals, my question is, how come insects that transmit anthrax don't die from anthrax? And so we've been studying this for several years. Now we have an understanding. But the basic methodology, if you're curious, is okay, it even has a sound. As you may know, if you heard on the news, anthrax killed several people in the United States 18 years ago, and it's been a main interest for bioterrorism. But lately, it's been noticed that it has become a kind of a threat to wildlife in Africa and savannas. So again, the question we're trying to ask is, how come Drosophila, which is the model for flies, or our mosquitoes don't die from anthrax? So our kind of model is, we have these flasks where we put some water-absorbing papers called Whatman papers at the bottom. We put in sugar solution that insects like to drink and eat. We put insects inside, and we cover them with those logs. And at the bottom here, we may add bacteria or bacterial toxins or drugs, and in some conditions, flies or insects will be alive and bouncing, and in the other conditions, flies will die. So we're asking a question: why in some instances insects are resistant, and in some instances insects are sensitive to anthrax? So I hope I covered both teaching and some of my research as well.